Hello Internet, welcome to Physics in 2D. I don't know what I'm going to call this yet. Anyway, you saw that box just slide over this hole here. So what I've done is I've set up a really quick scene. I can show the gizmos, but there's actually a little hole here. I made 3 box colliders there, and then this box also has a collider. So I actually have a second crate that is up here. If I start this again, you'll see this crate is the exact same, and it actually falls into that hole. So what we're going to be trying to solve this video is we're going to be trying to figure out how to get that moving crate, say you're pushing it, you're pulling it, whatever, in your game. We want that crate to fall in this hole, and that's going to require some 2D stuff. I think I know how to solve it. I think it actually might be easy. So we have this collision detection flag here. Right now it's set to discrete. So it's going to check collision at the beginning and the end of its movement. So it's going to check at its collision every time it moves. If we set this to continuous, it should check collision continuously throughout its movement. So if you have a really fast moving object, it should check collision, and it doesn't work. Shoot. Okay. So that doesn't work. Never mind. We don't need that. Usually what you use like that continuous collision detection for is, say you have like a rocket, for example, and say if you're familiar with what's a good example? Like any game that has any moving object. Unreal Tournament's rocket launcher, for example. If you have that, those rockets move pretty fast, and if you're running at them, you could theoretically run through the rocket and it would never collide with you. And so if that's in your game, what you want to do is you want to enable this continuous collision detection. That doesn't appear to solve our problem, so we're going to need something else. The solution I'm leaning towards is not using physics at all and using some sort of like grid-based system. But I'm not sure that's going to work. So, alright, I had to break out the whiteboard for this one. It's a little bit more complicated than I wanted, and I don't really know if my recording setup is set up for this, but we're going to try it anyway. And I think I've already kind of run through the solution, so I think this is going to work. I hope this is going to work. But here's what we're planning. So we've got our little pit here, like so. We've got our box. Now the box is going to go over our pit, and we're going to cast from the bottom point, the bottom center. We're going to do 2 raycasts at like a 45-degree angle. Should be fine. And what these are going to do is we're going to get a distance of both of these. And now we know, assuming that this is your block size, we can actually make this a little bit easier. So, if the length of the x length of this is greater than half the width of the box, it sounds a little bit complicated, but if x is greater than the width over 2, oh, my camera is flipped. I may have to do some post stuff. Oh, whoops. Anyway. So if x is greater than the width over 2, what we're going to get is we know that this cube can fall down because we know it's past the ledge. So what we can do then is we can actually move it back to that point. So we can set it so that x is equal to the width divided by 2. So we can get the x position of this wall, and then we can add the width over 2 to that. And theoretically, if we do that, our cube should align perfectly with this. I foresee floating point errors because all of this stuff is going to be happening in floats, so it may kind of hit this edge a little bit. So we may have to do some fudging of numbers, but I think this should work. And so we should be able to do that. And we can actually, this ray here I don't know if we even need that because I don't know if we're going to be using that at all. I was going to add that just so we can see if it can fall at all. Because say you have a really big box like so, and you have a really small little hole. This doesn't really fit. So even though this raycast may work, it doesn't work. So we're gonna have to play with that. But I think that we can work with this. I think that's what we're gonna do. I hope you can see that. Anyway, all right, we're back to our cube thing. So this is identical to what we have. I have a ton of post-processing effects, which is why it looks kind of like this. And I'll stick the asset that I'm using for all of these effects in my description, like I always try to do when I use these sort of assets. So we have our crate. Currently I just have this sliding box script, which just sets its X velocity to be a constant. We can mess with this a little bit. And I don't know if we want... Let's make a separate falling box script. And so this is going to need... Sure, I'll reload it. I may need to close this again because usually reloading breaks things, but it seems to have worked. Nope, never mind. I spoke too soon. All right, we'll close it, open it again. And now we can set our require component to a type of Rigidbody 2D. And so everything we're working with, even though I have 3D assets in here, I'm using 2D colliders to do this. It should be the same for 3D, but with the algorithm we have planned, you're probably going to need to do some extra work, a bit of extra work, just because you're moving in two directions. You have a 2D plane instead of just a line, so you've got an extra dimension to play with, which makes things a little bit harder, but you should still be able to solve it. It's just going to be harder. So let's get a reference to our rigid body. I'm just going to inject this automatically in the start. So we'll just do rigid body here. I'm going to stick on new because it's a rigid body and Unity already has a rigid body. It's deprecated, so you shouldn't be using it. You should be doing something like this. But it does exist, so if you're going to do that, stick this new there and it'll get rid of a warning. I don't think Unity shows the warning, but it's a warning it nonetheless. So we've got our rigid body. We want to get it from the component like so, and that should be that. Next, let's do our... So I'm going to actually stick this in the fixed update, which the fixed update is a little bit different than the update. It fires at a fixed interval based on the physics. So this is going to update when the physics updates, not when the screen necessarily updates, which can get a little bit confusing, but if you're working a lot with physics, this is the one you want to use. Then I think we just need one. So we're going to do a new ray. And this is going to depend on our velocity. .x. So if the velocity.x is greater than 0, then we want our ray direction. Actually, I'm doing this wrong. This isn't how you do that. You need a 2D ray because it's 2D physics. You can't, if you use like ray or rigid body or all of those, that's all going to apply to the 3D realm of things. So you have to use all these 2D components. Most of them just have 2D tacked onto the end of the 3D version. But if you don't do that, it's not going to work. And you'll probably get some really, really weird results. So keep that in mind. The origin, we can actually, Unity should be able to just automatically convert from a vector 3 to a vector 2 for us. And it should just take the X and Y position, which is exactly what we want. We want to take the X and Y position and ignore the Z. And then the direction, is actually where I'm going to want this. So we're going to take our new vector 2, and I'm going to copy and move that over there. And so this is just it's called a ternary operator, and it's sort of a cheap if. And what it does is it evaluates the first function, and then after the question mark, if that initial condition was true, it returns that value. Otherwise, it returns the one after the colon. So the syntax is going to look something like condition, stop, there we go, condition, true, and then false is sort of how that's going to work. So if the condition is true, otherwise if the condition is false. I recommend only using them sparingly. I'm doing it here because it kind of makes a little bit of sense. We may actually pull it out, but a lot of the time it adds more confusion to the code, and you can see it's already a little bit harder to read than it would be. So we may actually end up pulling that out. We'll see. Actually, let's just get rid of that for now. We'll create a variable and we'll call it the ray direction. Sure. And then we'll plug that in to our function. So it's still a little bit shorter, but this way it's a little bit more readable. At least I think it's more readable. So hopefully that's an improvement. And if not, then oops. So I just want to make sure I got this right. So if our velocity is greater than 0, we actually want it to shoot the ray in the opposite direction. So we want it to the ray to go back towards where it was. So we're going to do, if the velocity is greater than 0, then we want to shoot the ray backwards, so negative. And if it's less than 0, then we want to shoot it forwards. So if the box is going this way, we want our ray to go this way. Then we have our fun little raycast, or array there. I'm going to do a raycast hit 2D, and I'll just call it hit because that's what I always call it. And we'll do a physics 2D dot raycast. And this should just take a ray, and I have to remember the syntax, and I don't. So we're gonna guess. Did I get it? I don't think I got it. Nope. What's your syntax? Does it not accept a ray? That's kind of weird. Why doesn't it? That's interesting. So apparently, unless I'm reading this wrong, I'm looking right at these 5 functions. Those are the raycast functions. Unless I'm reading this wrong, it doesn't accept array. So why did we even make that? I guess since we have it, we can just pull the values out of there. But that's kind of weird that that isn't there. Just to run through that, the way I got there is I just F12'd. I believe that's the default Visual Studio hotkey. It's saying I started debugging, and that's because I just fat fingered like 7 keys on my keyboard. But if you don't do that and just hit F12, it'll take you to whatever it is. There's also a way to pull it up. Since I'm going through all of these things, there's also a way to pull up, Alt F12. So I can actually pull it up right here. And it will just kind of do like a really smart window view and just pull up that window there. But you can do whatever works best for you. I usually just go to it because that's just what I've always done. So, all right, we're going to pull out these things. I'm going to do ray origin and ray direction. And then it doesn't give us an out either. Oh, it returns it. This is weird. This whole syntax is weird. I feel like this is wrong, but I think it's right. No, they didn't change it. Maybe I'm just doing something weird. We'll find out really shortly if I'm doing something wrong. All right, So we have our physics 2D raycast. I'm not going to add any like layer mask or anything. If you want to do that and kind of selectively collide with things, maybe you only want to hit raycast with your world, because technically your player could actually screw up this mechanic by like getting underneath a box so it doesn't think that it hit anything. You can play around with that. I don't particularly care, so we're just gonna get the basics here. So we're gonna add a width. I'm just gonna set it to 1. That's not gonna really work for us, but it's gonna be fine, I think. And then I'm gonna have the raycast just be 2 times the width, which should be more than we need because we're doing a 45-degree angle, and the most we need is the x to be the width over 2. So we could actually solve for that hypotenuse if we wanted to, or we could just give it a bigger number than it will ever be, and it will work. So we're gonna do it the easy way. Right. So we have raycast hit. We get this hit if we hit something. Then what? What do we want? So if the hit dot distance is greater than half the width, I'm going to actually create a variable for this called half width. And the reason I'm going to do that is because we're going to be using it a lot, and it will be easier to do the math once. That's not how you do that. Half width equals the width times 0.5f. And I'm doing floating point math here. I'm actually multiplying it by 1/2 instead of dividing by 2. And that's usually because multiplication has been faster. I don't know if it still is, but I'm pretty sure. And I don't know with modern compilers if that's worth it, but this is usually faster. There's actually an easier way. We can do a bit shift, but I'm not going to do a bit shift. And I don't think that works with floats anyway, so don't listen to me. I'm just rambling. Okay. Getting away from that, we have our hit distance greater than half the width. We do not need to do this, because we can base it off of our ray direction. And so, how can we get this to work? Well, we don't even need it. If the hit distance is greater than half the width, because we already have our ray going in the direction we need, then we know it hit something. Then we know we're over a thing. And so then we can set the target position equal to the hit point. That's not how we want to do that. We want to do a new vector 3 with the x equal to the hit point dot x plus half the width. So that's going to be the wall we hit plus half the width. So we're going to stop the cube there, and it should just fall straight down. Even though we have some velocity applied to it, I'm thinking that'll work. And then I'm just going to plug in its current position dot y and its current z position as well. So all this is going to do is, if it's over a hole, it's going to lock that x until it hits the ground. So this won't work if you want to like keep velocity when you push something off. You'll have to probably fudge some other things. You may need that other raycast going in the direction to see if it should stop or not. I'm just trying to get it to fall into a hole and kind of keep things simple. So hopefully this works. We'll find out really quickly. All I'm going to do is set the transform position equal to the target position. I'm going to actually spell that right. And I'm also going to log out quick the quick message locking the box with a new target position. There we go. And I think that's it. That should, what this should do is if our hit distance is half of our width, which is this, then it should work. I think. We'll find out. Let's go here, grab our crate, put our falling box script on it, give it the proper width. I believe it's 3.5. I'll have to check quick. 3.5. Awesome. And then let's see if it works. Well, that was disappointing. What else is happening here? All right, so if that doesn't work, then let's debug log the hit. I'm just going to log out the hit information, and we're going to see what it displays. That wasn't very helpful. Ah, there's a way to stack them. Yeah, collapse. So if you turn that collapse on, it collapses all of the same messages on top of each other and then just puts a number by how much you've received. So I've just get one every frame. Kind of makes your logs a little bit easier to understand. Oops. All right. Except that wasn't helpful at all. I'm gonna add a gizmo really quick. And I'm gonna move this out here. And the reason I'm doing this is so that we can actually draw it. On draw gizmos. Gonna set the color equal to like red, sure. And then I'm just gonna draw a line from the hit.or from this transform, keep hitting enter, position to the hit position. I'm kind of curious where this is gonna draw to. I don't think it's gonna be what we want, but I'm just curious what it is. Nothing. Well, why is that? It'll be like this box. Oh, fine. Object reference not set to something of an object, which is going to be it didn't hit anything. I'm going to log out the hit distance. That should help us. I should have been doing that from the beginning. That would have made sense. So we're getting null pointers because there's points when it doesn't actually hit anything. Ah. I know what's happening. It is colliding with itself. That wasn't entirely what I had in mind. So we can fix this. Where's my, there it is. I'm gonna pull it out of that didn't pull it out. I'm gonna pull it out of the object quick and just set its position equal to 0, and then reparent it to the crate. And so now it should be more or less at the bottom. And then ray origin is what we're going to call it. And we'll jump back to our thing, our falling box script. Let's add a public reference to a transform. And we'll call it the origin. And now we want to use that instead. So we still want to keep all of like this stuff the same, but when we're generating our ray, we want that to be based off of this origin point. So I think that's all we had to change. And then I'm just going to change the gizmo as well, like that. Somebody's got a dog. All right. Here we go. This should work. So many exceptions. I didn't actually assign it at all. Oops. I was so excited. I didn't actually do anything right. I do that too often. All right. Now let's try it. There it goes. We're still hitting our cube. You can see now it's drawing a line from our point here to the center of our box, and that's because it's hitting our box. So I think the solution to this is to actually drop it a little bit below the ground, or alternatively we can ignore the box. And I think that's the right way to do it. And there's actually a really easy way to do that. Just ignore raycast. And that, I believe that works. That dog is having way too much fun. All right. What? That wasn't what I wanted. Oh, okay. So it's doing something, and it's printing off a weird width. I believe it's moving afterwards. So we can kill the velocity, which is not what we want to do. But I'm just, at this point, I'm just going to riff on this a little bit and try to get it to work. So I'm going to set the velocity to a new vector 2 of 0 with a rigid body velocity equal to its y velocity. And this way, we need to do this instead of just setting it to the 0 vector. Because if we set the y to the 0 vector, or to the 0, it's not going to fall at all. And it's going to look really weird. Okay, we're getting closer. It's starting to work. Slowly. It's doing something weird there, but... and it keeps moving forward. I'm going to toggle off the sliding box bit. And I believe I should be able to... whoa. What is it doing? That's not what I expected at all. Okay. That was weird. It was colliding with something that I hadn't anticipated it colliding with. Okay. Moving on, let's figure out what that is. We have this, it's hitting, that's why, because our hit point. Oh, that does work, okay. That's why, it was colliding with this, and that's origin is right there. So that makes sense. I don't know though why it's drawing it all the way over there. That's a little bit weird, but we'll deal with that when we need to. Okay. There's our 45-degree X angle. Now I should be able to shrink this and it should get... Problem is... Yeah, it keeps going. So I'm gonna set this width to something tiny, just to prove that it locks and drops, which sounds like the name of a song or something. That's really weird. So what it's doing is it's like it's stopping and then it isn't stopping. I'm gonna just do something stupid. I'm gonna set the constraints. And I'm gonna do an OR equal to freeze position X. And this is just going to automatically toggle on its freeze position X when this happens. So it shouldn't move anymore. And then it should just go straight down. It won't go straight down because it hits there, but it shouldn't continue ever. Okay, that's good. Whoa. It's doing a little bit of weird stuff, but okay. There's so small of a margin for error. All right, I'm actually thinking I may have overcomplicated things with all this fun art stuff. So I'm gonna really quickly make some, yeah, this will work. This seems to be working. I'm not gonna do that. I'm just gonna say I'm gonna do that and then I'm gonna change my mind again and then, yeah. Anyway, all right, we have a crate. Crate should fall. Crate fallen whole. Okay, so it gets close, and the reason it's not falling in is because this value is wrong. How big? So 0.8 of 3.5. What is that? That is going to be 3.5 times 0.8. Because that's going to be how big our actual collider is. Because I think that box is smaller than the scale, than a 1-to-1, which is probably what's screwing me up. So, continuing with our really bad ideas, we're just going to multiply by 0.8f. The f's at the end are signifying that it's a float and not a double. C# is going to default to doubles. So if you don't put that f there, it's going to get really mad at you because we're trying to save floats into double form. Okay, did a little bit of a jump, but it was almost perfect. So 2.8 is the answer we were looking for. Jump. Now I don't know why that second one happens. Because you see we have a locking box, and then we lock it again at 2.8. My guess of what is happening is we are changing our velocity to be negative, and then bad stuff is happening. But that doesn't really make any sense. So we actually only need to do this if I'm going to do some quick math here. And what we're going to check is we don't want to do anything if the rigid body's velocity is 0. if it's not moving, this doesn't need to run. So there's a math approximately function, and you can use that to compare floating point numbers. You shouldn't use equals equals. Like if you try to say is a float equal to another float, you shouldn't do that because 0.1 as a floating point number is not actually 0.1. And so if you get there by like dividing 10 from 1 and also just typing like 0.1, those may not necessarily be exactly the same. So there's some weird floating point things that are going on. But what we can do is do if the rigid body dot velocity dot x is approximately equal to 0, then we don't need to do anything. So I'm just going to make this a not. And so if they're not almost the same, then do this. And because what was happening, what I think was happening, is it was hitting this, and then it was continuing to go through here and probably switching and doing some other weird stuff. And so we don't want that to happen. So this should fix that part. And then I'm curious what'll happen next. Okay, it didn't fall. Which is kind of what I was hoping for. I'm gonna select those. How close are we? Sorry, this is the annoying part of this. Trying to figure out where these colliders are, and that's really difficult. There's actually a better way to do this, isn't there? I can hide things. One sec. That didn't really do what I anticipated. Okay, it has a box collider. Where is it? Why is it gone? And you can actually see those floating point errors we were talking about. This 0.8 is actually 0.80000000001 because that's just how floating point numbers work. So it's a little bit annoying. I believe what happened. That is what happened. It's just a little bit too big. So I think that's as close as we can get it. It was being a little bit weird there. I still think that's broken. We can run this quick, see if it works. Yeah. Good news. 0.79 seems to work. So we have like 1/100th of a precision, which is pretty good. And it does that little shifty magoo thing. Huh, okay, let's fix that too. What is happening with that? Oh. Locks the box a bunch. And then it starts shifting over. Oh. I know what's happening. It is hitting the bottom. It's hitting the floor. And so when it's doing that, then it's obviously not going to work. But if it's hitting the floor, the raycasts... Oh. Derp. Okay, I know how we fix that. That's the wrong project. Anyway, we're comparing the distance. That's not right. We want to compare blarg the... Where is it? It's a fraction. What's that for? Fraction is the distance along the ray that the thing occurred. Centroid? Okay, there's a bunch of stuff here. We're going to have to do some math though. And so what we need is we need a vector 2 of the collided point. Collided length, I think that'll work. And this is going to be our origin position minus the hit point. And I believe this is in world space, so we're good. I don't think it likes subtracting that. It can't do... No? Okay. Let's create a new vector 2 from this origin. This is going to be one of the world's slowest scripts. We're just creating so many objects in this, it's probably not a good idea. Actually, we don't need to even do that. We can just get a float here of the collided length and just do the origin position dot, that's not how we do that, the origin position dot x minus the hit point dot x. And so this is going to get us in the x space the collided length. And then we can compare that to half the width. And so this, since we're now comparing half the width, it has to travel half the width horizontally, otherwise it won't do its thing. So this should solve our problem, I think. We could actually probably solve this better by just doing straight horizontal lines by moving the point just slightly below the cube and then just casting it directly horizontally. That may actually be a better solution. So if you guys want to explore that, go for it. I'm gonna just continue on with this and we'll see what happens. But we've got the collided length now, so I'm gonna plug that in and it should just fall. Ta-da! So there we go. And there is mostly perfect. I had to kind of tweak the numbers a little bit, and maybe there's a better solution to this, but this is sort of what I thought of when I was asked about it. So I hope this is helpful, and I hope you guys enjoyed it. If you did, let me know. I'm curious what you guys think. So if you liked it, hit the like button. I can't word right now. And yeah, I'll have to see you guys in the next one. So until then, see you, Internet.